What is an ellipse? You might describe it as a squashed circle, which would be correct. But in mathematics, an ellipse has a much more specific definition, which is a closed curve where the sum of the distances from the two focus points inside the curve to every point on the curve is constant. An ellipse is not to be confused with an oval, which does not have a lovely mathematical definition like the ellipse does. Let's take a look at an ellipse so we can see those two focus points, which together we call foci. We can illustrate the mathematical definition of an ellipse by showing a point on the ellipse along with connecting lines to the foci. If we measure these two line segments and then add them together, that will be the total length from any point on this ellipse to the two focus points. Depending on where the point is on the ellipse, the blue line will sometimes be shorter and the red line longer, but they'll always add to the same amount. Now let's talk more about those focus points. We find them on the major axis of the ellipse, which is always the longer of the two axes. Depending on the ellipse, the foci get closer to or farther from the center. Look at this ellipse that's not quite as squashed. Notice how the focus points are closer to the center of the ellipse in this one. This is due to something we call eccentricity, which is expressed as a value between 0 and 1. We can calculate the eccentricity by creating a ratio. We measure the distance from either focus point to the center and place that over the distance from that focus point to either end of the minor axis. When the eccentricity is 0, we have a very special kind of ellipse that we call a circle. When that happens, it means that the two focus points have converged into one point at the center of the ellipse. At the opposite end of the spectrum is a totally flattened ellipse, and those two measures will be the same, resulting in an eccentricity of 1. It also means that our ellipse will look like a line segment. It's totally flattened with the foci as endpoints of the line segment. Here's the standard form of an equation of an ellipse. X minus h squared over a squared plus y minus k squared over b squared equals 1. We have a lot of letters to define here. The center of the ellipse is represented by h and k, which form an ordered pair. The coefficient a is the length from the center of the ellipse to either end of the ellipse parallel to the x-axis. And b is the length from the center to either end of the ellipse parallel to the y-axis. We can see that in this case, b is equal to half the length of the major axis, which in this case is the height of the ellipse, and a is half the minor axis, which is the width. So if we want to create an ellipse with a height of 14 units and a width of 10 units, b would be equal to half of 14, which is 7, and a would be equal to half of 10, which is 5. If we wanted that ellipse to be located with a center at -3, 2, our equation would look like this. X plus 3 squared over 25 plus y minus 2 squared over 49 equals 1. We substituted the x and y values of our center, -3, 2, for hk. Notice that since h is negative, it changes the sign inside the left binomial to a plus sign. This is because subtracting -3 is the same thing as adding 3. Our denominators are just the squared versions of our a and b. A is 5, which squares to 25, and b is 7, which squares to 49. Okay, to wrap things up, let's go through a couple of practice problems. Feel free to pause the video after each question to work it out on your own. Number 1. What is the equation of an ellipse that has a center at 6, 4, has a height of 12, and a width of 8? We start with the standard form of an equation for an ellipse. X minus h squared over a squared plus y minus k squared over b squared equals 1. Next, we substitute the x and y values of the center for h and k in our general equation. X minus 6 squared over a squared plus y minus 4 squared over b squared equals 1. Finally, we take half of the width, which is the minor axis, to find our value for a. Half of 8 is 4. We then square it after substituting it into the general equation for our first denominator of 16. We do the same thing for b. Take half of the height, half of 12 is 6, and substitute it in for b, where it is squared to become 36. Done! X minus 6 squared over 16 plus y minus 4 squared over 36 equals 1. Number 2. What is the equation of this ellipse? This one is a little tougher because we need to find the length of both axes as well as find the center of the ellipse. We start with the standard form of an equation for an ellipse. X minus h squared over a squared plus y minus k squared over b squared equals 1. Next, we need to determine how tall and wide our ellipse is. By looking at the diagram, we can see that it is 8 units tall and 6 units wide. We also need to find the center, which we can do by drawing the major and minor axes. Here we find the center at -1, 1. Now we can substitute the x and y values of the center for h and k in our general equation. X plus 1 squared over a squared plus y minus 1 squared over b squared equals 1. When we substitute the h, we end up with x minus -1 squared, which can be written as x plus 1 squared, because subtracting a negative is the same thing as adding. Finally, we take half of the width, which is the minor axis, to find our value of a. Half of 6 is 3. We then square it after substituting it into the standard form equation for our first denominator of 9. We do the same thing for b. Take half of the height, half of 8, which equals 4, and substitute it in for b, where it is squared to become 16. X plus 1 squared over 9 plus y minus 1 squared over 16 equals 1. That's all for this review of ellipses. Thanks for watching and happy studying.